Okay, so here are two examples about proportion, how to solve the problems in real world situation. One, the cost for water in the city Bradenton, Florida is $2.14 per 1,000 gallons of water used. What is the water bill if 25,000 gallons of water are used? So we are given the ratio between the money, how much you are paying, and how much gallons of water you are using, right? So we can use the proportion of $2.14. This is money, how much you are paying, for how many gallons of water? 1,000 gallons. So this is the ratio. It's like $2.14 per 1,000, right? So you can use this proportion. I mean, you can use this ratio and write a proportion of money that you are paying when you are using 25,000 gallons. So you can compare these two ratio with the dollars in the numerator and the gallons in the denominator. Make sure you have the same order. If you are putting the dollar first and gallon later, you need to do the same thing in the second ratio to set up an equation, the proportion. Okay, now what we can do is you can do cross multiplication. So you don't know how much you're paying, so that is your x. Then using the cross multiplication, you can do 1,000 gallon times how much you're paying is equal to, now this side, $2.14 times 25,000 gallons. So you can see that gallon is here and there. So you can, if you divide both sides by gallons, it will be cancelled. If you divide the dollars on both sides, it will be cancelled. So you don't need to pay attention to the units anymore. Now you have 1,000x. 1,000x is equal to 2.14 times 25,000. So you can divide both sides by 1,000 to solve for x, right? So divide both by 1,000. Then x is 3 zeros, 3 zeros. It's same as 2.14 times 25. So when you're calculating that, let me use my calculator. That is 2.14 times 25 is equal to 53.5. 53.5. Our x is how much you are paying when you are using 25,000 gallons of water. So it's gonna be $53.50. That's your unit, right? Okay, let's look at the next problem. Insulin comes in vials labeled with the number of insulin units per cubic. Insulin units per cubic centimeter of fluid. An insulin vial labeled U40 has 40 insulin units per cc cubic centimeter of fluid. Tyler's insulin dosage is 30 insulin units. How many cubic centimeters are needed for Tyler's dosage? So we are given U40 has 40 insulin units per cc, right? So 40 units per 1 cubic centimeter, 1 cc. Per cc of fluid means per 1 cubic centimeter. With this ratio, now Tyler's insulin dosage is 30 insulin units. So you see, I put units in the numerators, right? And you need to figure out how many cubic centimeters are needed for his dosage. We can get to know, I mean, using number sense, it will be less than 1, right? Because we have less units. So you can check your answers in that way. Now you set up a proportion, and now you can use the cross multiplication. So 40 times x, you can ignore the unit because as you have seen in the previous examples, the units will be cancelled, right, when you do multiplication, cross multiplication. So you can just do 40 times x is equal to 30 times 1, which is 30. So you can divide both by 40, then your x is 3/4, which is 0.75, right? So it is less than 1 cc. So yeah, we can use our number sense to check. So how many cubic centimeters are needed? 0.75 cc. Okay, so that's the examples, and I'm pretty sure you are able to solve all the problems in the homework. And if you are stuck with anything or if you have any question, please let me know. See you on Friday.